Moving on to the question number 1. Let triangle ABC is similar to triangle DEF and their areas be respectively 64 cm square and 121 cm square. If EF is equal to 15.4 centimeters, find BC. Now moving on to the solution. He has given that triangle ABC is similar to triangle DEF. So let us draw both the figures. Triangle ABC is similar to triangle DEF. So when two triangles are similar, then their corresponding sides will be in proportion. So we can say that AB by DE is equal to BC by EF is equal to AC by DF. And now if we draw a perpendicular height, that is AP and DQ perpendicular to the bases BC and EF respectively, then these proportions will be also equal to AP by DQ. We know that area of triangle ABC is equal to half times base, which is nothing but BC, into height AP, and area of triangle DEF is equal to half times base, which is EF, times DQ. But he has given that area of triangle ABC is 64 cm square and area of triangle DEF is 121 cm square. So now let us divide area of triangle ABC by area of triangle DEF, so that we get half times BC times AP divided by half times EF times DQ, which is equal to 64 cm square by 121 cm square. As centimeter is common in numerator and denominator, that will be cancelled, which implies here also in numerator half and in denominator half will be cancelled. So we can write this as BC by EF into AP by DQ, which is equal to 64 by 121, which implies BC by EF into, from here we can say that AP by DQ is equal to BC by EF. So by substituting that, we get BC by EF into BC by EF is equal to 64 by 121, which implies BC by EF into BC by EF is nothing but BC by EF whole square, which is equal to 64 by 121 can be written as 8 by 11 whole square, which implies, now by taking square root on both sides, we get BC by EF whole square under root is nothing but BC by EF, and that will be equal to 8 by 11 whole square, square root will be equal to 8 by 11. Here the value of EF is given as 15.4 and we are asked to find the value of BC. Therefore we get BC by EF is nothing but 15.4 given, which is equal to 8 by 11. Now by transposing 15.4 to right hand side, we get BC is equal to 8 by 11 times 15.4, and 11 goes in 15.4 1.4 times, and 8 times 1.4 is nothing but 11.2 centimeters. Therefore finally we got BC is equal to 11.2 centimeters. Moving on to the question number 2. Diagonals of a trapezium ABCD with AB is parallel to DC intersect each other at point O. If AB is equal to 2CD, find the ratio of areas of triangle AOB and COD. Now moving on to the solution. he has given a trapezium ABCD with AB is equal to 2 times CD, which can be written as AB by CD is equal to 2. Now he also says that BD and AC are the diagonals which intersect at O. So as he asks the area of triangles AOB and COD, let us find out them, which will be equal to half times AB, which is base for triangle AOB, and let us assume OPB, height for the triangle AOB, divided by half times in triangle COD, CD be the base, and let OQ be the height, which is equal to AB by CD into OP by OQ. As we know that AB by CD is nothing but 2 times OP by OQ, let it remain as it is. Now if we consider triangle AOB and triangle COD, let us assume that CD is parallel to AB and BDB transversal. Then angle CDO is equal to angle ABO because they are alternate interior angles. And similarly, let again assume that CD is parallel to AB and AC is transversal. Then angle DCO is equal to angle OAB because they are alternate interior angles again. If we observe clearly, in triangle AOB and triangle COD, 2 angles are equal. The corresponding sides are in a proportion of 2. So now we can say that triangle AOB is similar to triangle COD. When 2 triangles are similar, then their corresponding sides will be in same proportion. So we can say that AB by CD will be equal to the same proportion of sides. Let us take here heights, that is OP by OQ. So now that implies OP by OQ becomes AB by CD is given as 2. So let us substitute in the area of triangle AOB by area of triangle COD, which is equal to 2 times OP by OQ, which is equal to 2 times OP by OQ is nothing but 2, which is equal to 4. And this can be written in the ratio form as 4:1. Moving on to the third question. In figure 6.44, ABC and DBC are 2 triangles on the same base BC. If AD intersects BC at O, show that area of triangle ABC by area of triangle DBC is equal to AO by DO. Now moving on to the solution. Given that ABCD is a quadrilateral in which ABC and DBC are 2 triangles lie on the same base BC, and diagonals AD and BC intersect at O. Now we are required to prove that area of triangle ABC by area of triangle DBC is equal to AO by DO. Now in order to do this, let us have some construction. Draw DP perpendicular to BC and AQ perpendicular to BC. Now moving on to the procedure. In triangle AOQ and triangle DOP, angle AQO is equal to angle DPO is equal to 90 degrees, as AQ is perpendicular to BO and DP is perpendicular to OC. And here angle POD is equal to angle QOA because they are vertically opposite angles which are equal. Now, as two angles are equal by AA similarity, we can say that triangle AQO is congruent to triangle DPO. By this, when two triangles are congruent, we can say that their corresponding sides will be in proportion. Therefore, we can write AQ by DP is equal to OA by OD. Let it be as equation number 1. Now, if we consider area of triangle ABC by area of triangle DBC, this will be equal to half times base is BC into height is nothing but AQ here divided by area of triangle DBC is nothing but base BC here and height is DP. So that will be equal to, as half times BC is common in numerator and denominator, it will be cancelled and we are left out with AQ by DP. We have got that AQ by DP is equal to OA by OD in the first equation. Let us substitute that. So we can write OA by OD as AO by DO, which is the required proof. Now moving on to the fourth question. If areas of two similar triangles are equal, prove that they are congruent. Now moving on to the solution. For our simplicity, let us consider two right angle similar triangles, triangle ABC and triangle DEF, which are just similar. Now, as triangle ABC is similar to triangle DEF, we can write corresponding sides in proportion, that is ABC by DE is equal to BC by EF, that will be equal to AC by DF. Now, let us find the ratio of two triangles, or he has given that area of two similar triangles are equal. So, he has given that area of triangle ABC is equal to area of triangle DEF. Then it becomes half times base is BC into AB height is equal to half times base here is EF times height here is DE. That implies half and half will be cancelled on both sides of equality, and we can write this as BC by EF is equal to DE by AD. So here we have BC by EF is equal to AB by DE1 and BC by EF we got it as DE by AB. Let us equate them. Then we get AB by DE is equal to DE by AB. That implies AB square is equal to DE square. Now by applying the square root we get AB is equal to DE. Similarly, as AB by DE is equal to 1 we get, as they are equal, we can say that AC by DF is equal to 1. which implies AC is equal to BF. Now accordingly we can write, we assume that angle ABC is equal to angle DEF is equal to 90 degrees, and we got that AB is equal to DE and also AC is equal to DF. Therefore, from RHS property, we can say that triangle ABC is congruent to triangle DEF. Therefore, two similar triangles with same area will be congruent. Moving on to the sixth question. Prove that ratio of the areas of two similar triangles is equal to the square of ratio of its corresponding medians. Moving to the solution. Let us consider two triangles ABC and triangle DEF which are similar. Now in this, let us assume that AM and DN be the medians from A to M and D to N in triangles ABC and DEF respectively. Then in triangle ABC, BM is equal to MC, and in triangle DEF, EN is equal to NF. Now, as we know that triangle ABC is similar to triangle DEF, then the sides will be in proportion. Therefore, we can write as AB by DE is equal to BC by EF is equal to AC by DF. And we also know that the ratio of area of two similar triangles is equal to square of ratio of its corresponding sides. Therefore, here we can write area of triangle ABC by area of triangle DEF is nothing but square of ratio of its corresponding sides, that is AB by DE whole square, which can be written as AB square by DE square. Now in these two triangles, if we consider the two triangles, that is triangle ABM and triangle DEN, from first triangle similarity, that is ABC is similar to DEF, we get AB by DE is equal to BC by EF. And now we know that BC is equal to BM plus MC, and as BM is equal to MC, we can write BC as 2BM divided by, and EF we can write it as 2EN, as EF is equal to EN plus NF and EN is equal to NF, which is equal to BM by EN. From this whole we can write that AB by DE is equal to BM by EN. And also we know that triangle ABC is similar to triangle DEF. We can say that angle ABC is equal to angle DEF, or this can be written as ABC. Instead of ABC we can write ABM angle, which is equal to angle DEN, which is nothing but angle DEF and angle ABC. Now if we observe, in triangle ABM and triangle DEN, two sides are in proportion and one angle is equal. Therefore, by SAS similarity, we can say that triangle ABM is similar to triangle DEN. And we know that if two triangles are similar, then their sides will be in proportion. Therefore, we can write AB by DE is equal to BM by EN is equal to, let us consider the AM and DN, those will be also in proportion. Now, instead of AB by DE, in the equation 1, let us replace AM by DN. Then we get area of ABC divided by area of DEF is equal to AB by DE whole square, which is equal to, here it is AM by DN whole square, which is equal to AM square by DN square. Here we got the ratio of areas of two similar triangles as square of ratio of its medians. So that's what the proof required. Moving on to 7th question. Prove that the area of an equilateral triangle described on one side of square is equal to half the area of equilateral triangle described on one of its diagonals. Now moving on to solution. Let us consider the square ABCD and let the equilateral triangle described about the side be BCE, and let us assume that AC is diagonal and equilateral triangle described about it be ACF. Then here, as BC is equilateral triangle, BC will be equal to CE will be equal to EB, and as ACF is equilateral triangle, AC will be equal to AF will be equal to CF. Now in both the triangles, that is triangle BCE and triangle ACF, angle B is equal to angle C is equal to angle E is equal to 60 degrees, and angle A is equal to angle C is equal to angle F is equal to 60 degrees. So as the corresponding angles, that are all the three angles of two triangles are equal, by A similarity, we can say triangle BCE is similar to triangle ACF. As two triangles are similar, let us consider the ratio of area of triangles, that is area of triangle BCE divided by area of triangle ACF. We know that when two triangles are similar, then ratio of their areas will be equal to square of ratio of their sides, that is BC by AC whole square, which is equal to BC, let it remain as it is, by, we know that diagonal of a square is nothing but root 2 times its side. So we can say AC is equal to root 2 times BC. So let us substitute that root 2 BC whole square, that is equal to BC and BC, numerator and denominator will be cancelled, and 1 by root 2 whole square will be left. 1 by root 2 whole square is nothing but half. So here we got area of triangle BCE is equal to half times area of triangle ACF. Here BCE is triangle described about side and ACF is triangle described about its diagonal of the square. So here we proved that area of equilateral triangle described about one side of square is equal to half times the area of equilateral triangle described about its one of its diagonals. This is what the required proof for us. Moving on to the 8th question. ABC and BDE are two equilateral triangles such that D is the midpoint of BC. Ratio of the areas of triangle ABC and BDE is. Now moving on to solution. He has given a triangle ABC, equilateral triangle in which AB is equal to BC is equal to CA, and he says D is midpoint of BC and triangle BD is formed such that it is also an equilateral triangle. So here, as BDE is an equilateral triangle, we can say BD is equal to BE is equal to DE, and as D is midpoint of BC, we can say BD is equal to half times BC. As ABC and BD are equilateral triangles, angle A is equal to angle B is equal to angle C is equal to 60 degrees, and in triangle BDE, angle B is equal to angle D is equal to angle E is equal to 60 degrees. In both the triangles, the corresponding angles are equal. So we can say the two triangles are similar. So that is triangle ABC is similar to triangle BDE, and he asked the ratio of area of two similar triangles, that is area of triangle ABC by triangle BDE will be equal to. We know that when two triangles are similar, then ratio of area of both the triangles will be equal to ratio of square of the corresponding sides, that is here corresponding sides are AB by BD whole square, that is equal to AB is nothing but BC divided by BD, we know that half BC whole square, that is equal to, by interchanging BC will be cancelled and 2 will be going to 2 square, that is equal to 4. So here we got the ratio of area of triangle ABC and BDE as 4, that is nothing but 4:1. So option C is our answer. Moving on to 9th question. Sides of two similar triangles are in the ratio 4:9. Then area of these triangles are in the ratio. Now moving on to solution. He has given the sides ratio of two similar triangles, that is 4:9. And he asked us to find the ratio of areas. We know that ratio of areas of two similar triangles is nothing but square of ratio of sides, that is 4/9 whole square here, which is equal to 4 square is nothing but 16 by 9 square is nothing but 81. So overall ratio will be 16:81. That is our solution, and here it is option D.